Session 4. In this session, we are going to study about electromagnetic force. If two resting particles are having charge of Q1 and Q2 respectively, and both are at rest with respect to the observer. Also, if they have distance r between them, then the electromagnetic force can be defined as by the formula 1 upon 4 pi E naught into Q1 into Q2 divided by R square. Let's try to understand this. Suppose there are two charged particles, Q1 and Q2. Charge on first particle is Q1, charge on second particle is Q2. They are R distance apart, and this has been observed via observer. Then the electromagnetic force acting on both the particles is 1 upon 4 pi E naught into Q1 into Q2 divided by R square. Here E naught is equals to 8.85419 into 10 power minus 12 Coulomb square divided by Newton meter square. This E naught is also called vacuum permittivity constant. Thus, by putting value of E naught on this equation, we can write this bracket as 1 upon 4 pi E naught is equals to 9 into 10 power 9 Newton meter square per Coulomb square. This is to be noted that when the charge Q1 and charge Q2 have different charges, then the type of force will be different accordingly. Let's suppose the charge on Q1 is positive. The charge on Q2 is positive. Therefore, the force will be repulsive. Case 2. If charge on Q1 is positive, charge on Q2 is negative, force will be attractive. Case 3. If charge on Q1 is negative and charge on Q2 is positive, force will be attractive. Case 4. If charge on Q1 is negative, if charge on Q2 is negative, then force will be repulsive. So conclusively, we can say that if charge on both the particles are same, then the force will be repulsive. If charge on both the particles are different, then the force will be attractive. Like here, charge on both particles is positive. Also here, charge in both particles are negative, then the force is repulsive. Similarly here, if the charge on one particle is positive and the other particle is negative, then the force will be attractive. Let's see the example where there are two hydrogen atoms and are 1 meter apart. So we have to find out that the number of forces acting on each particle. Here in the diagram it is depicted that there are two hydrogen atoms, atom 1, atom 2. Both the atoms contain a proton and a neutron. This is proton and neutron of atom 1. This is proton and neutron of atom 2. Thus, solving the problem, here we can see that the number of particles in one atom is 1 proton plus 1 neutron. Number of particles in one atom is 1 proton, 1 neutron. Thus, total number of particles is 2. Total number of atoms is 2. This is atom 1. This is atom 2. So total number of particles in the system is 4. This is 2 plus 2. 2 plus 2. Total number of particles 4. Force acting on each particle is equals to 3. Let's see how 3 forces are acting on each particle. Let's consider force acting on the neutron of atom 1. it has been showcased by the orange color. So we have to find out wherever the orange arrows are moving, or from how many directions this neutron of orange color is getting forces. So the first thing we can see is it is getting force from yellow arrow. This yellow color is of neutron of second atom. Similarly, it is also receiving a force of blue color from this blue particle, which is proton of second atom. Also, this is receiving a force in form of red arrow, that is from the red particle, and that is from the proton of its own atom. So, neutron of the atom 1 is getting three forces. So those forces are from proton of its own atom, proton of the second atom, and neutron of the second atom. So neutron of the first atom is getting three forces. On the similar pattern, we can find out that neutron of the second atom is getting three forces. That is one from the neutron of the first atom, second force is from the proton of the first atom, and third force is from the proton of its own atom itself. In the similar fashion, we can see that the proton of the second atom is also facing three forces. The first force is from proton of the first atom, the second force is from the neutron of the first atom, and the third force is from the neutron of its own atom, and vice versa for the proton of first atom. Therefore, total number of forces acting on complete system is, here its system is said to be of containing two hydrogen atoms. Force acting on each particle is 3 and total number of particles are 4. So total number of forces would be equal to 4 into 3 is equals to 12. The next thing we are going to study here today is nuclear forces. Nuclear forces act only on proton and neutron of an atom. These forces are highly attractive and have a very short range. When separation between the particle is greater than 10 to the power 14 meter, then Coulomb's force is stronger than nuclear force. On the other hand, if the separation between the particle is 10 to the power minus 15 meter or less, then nuclear force is stronger than Coulomb's force. This nature of having attraction at 10 to the power minus 15 meter causes the nucleus to be stable. Thus, nuclear forces allows a nucleus to be stable. The example of such forces are nuclear fission and nuclear fusion. The next forces that we are going to study is weak force. Have you heard the term negative beta decay? Let me tell you. A neutron has the ability to transform into proton while also emitting an antineutrino and an electron. The term for this is negative beta decay. The force responsible for these are known as weak forces. Weak forces are also have smaller range than the size of neutron and proton. Therefore, these weak forces also come under the category of quantum physics. Thus, its effect can only be seen in the neutron and proton only. The next thing we are going to study is momentum. What is momentum? Momentum is a vector quantity and it represents the mass that is in motion. Here, it can be calculated as product of mass and velocity. As we can see, this is an object of mass m moving with a velocity v. Therefore, momentum of the object can be written as P is equals to mv, where P is denoted for momentum, m is mass of object, v is velocity attained by the object. Since the unit of mass is kg and the unit of velocity is meter per second, therefore the derived unit for momentum is kg meter per second or Newton second. In a uniform motion where the velocity is constant, momentum will also be constant. Let's try to understand this. Suppose if a body of mass is moving with a velocity v, the mass of the body is never going to change by itself. So mass will definitely be m at every point of time. And we have considered that the velocity is constant, and velocity, that means the velocity is also not changing. So if both mass and velocity are not changing, that is that if the both are constant, then momentum will always be constant. The next thing we are going to study is torque. What is torque and what is its unit? Torque can be described as the twist or angular force provided to an object around an specific axis. In other words, it is the product of magnitude of force and perpendicular distance from axis of rotation. Let's try to understand these in the form of pictures. Here, a horizontal bar has been given a torque. Here, the torque can also be said as the rotational force. Therefore, it has been written as F, the rotational force. Rotational force is also called torque. So, when a rotational force is provided on a horizontal bar through an axis of rotation, the horizontal bar will revolve. This is called torque. Force is also a vector quantity and torque is the rotational force. So, in these things, generally the objects will try to rotate or revolve. In force, the object can move in a linear direction as well. In the same picture can be visualized like this also. This is the side view of the picture and this is the top view of the picture. When a force is applied on a horizontal bar, the bar will try to rotate along an axis. That axis is called the axis of rotation. This is the axis. This is the direction of rotation. This is application of force on a horizontal bar. At time is equals to 0, when force equals to 0, the horizontal bar was at rest. But at time is equals to t, the horizontal bar would be somewhere here due to the application of rotational force on the axis of rotation. Consider an object of length r on which F force is applied from its one end. Therefore, the torque can be defined as force into distance from the axis of rotation. Here in this case, it is the length of the horizontal bar. Torque here is represented by the letter capital T. Also, it has been generally mentioned with the Greek letter tau. Tau is equals to force into the displacement. Displacement is distance from the axis of rotation. Force, application of force from the distance of axis of rotation. Thus, its derived unit is Newton meter and it is a vector quantity. Let's try to understand this torque by an exercise. The question says, an internal hexagonal bolt is to be opened using a wrench of length 0.3 meter. The force applied by hand through wrench is 3 newtons. Find the torque on the bolt. So, given the length of the wrench is somewhere 0.3 meters. 0.3 meters. The force applied through the wrench is 3 newtons. The force applied is 3 newtons. Therefore, torque applied by wrench is force into the length of the wrench. The formula of torque is magnitude of force into distance of the point from the axis of rotation, which is 0.3. In our case, 0.3 meters. So 3 into 0.3 will lead to 0.9 Newton. So for opening a bolt or loosening a bolt, a 0.9 Newton of force is to be needed. And so is the answer of our question. Here we summarize the today's session. In this session, we have covered the following things. The first thing that we have covered is Newton's first law. Newton's first law states that a body at rest or in motion remains to be at rest or in motion until and unless an external force is applied on it. This is due to inertia. That is, a body, when it is at rest, it would be at rest only if no external force is applied on it. Similarly, if a body, if it is in motion, it will be in motion only until and unless an external force is applied on it. For example, suppose a vehicle is moving with a constant velocity of 10 meters per second. Until and unless the braking force is applied, it would not stop. On a similar fashion, if a vehicle is standing still on the road, until and unless the engine force allows its tire to move, it would not start to move. So it would tend to be at rest if at rest, and if it is in motion, it would be in motion until and unless an external force is applied. The second key point we have learned today is Newton's second law of motion. Newton's second law of motion states that rate of change of momentum of a body is equal in both magnitude and direction of the force applied on it. By deriving the second law, we have found out that force is equal to product of mass and acceleration, where mass is mass of object and acceleration is the acceleration achieved by the object. Thus, we figure out that the acceleration of a particle can be measured as the sum of forces acting on it divided by its mass. We have simplified that equation for acceleration. Previously, we have termed it as force is equals to mass into acceleration, F is equals to ma. Now for finding particularly acceleration, we have simplified that is A is equals to F upon m. Further, we have learned Newton's third law of motion. The Newton's third law of motion states that every action has an equal and opposite reaction. The example we've preferred for this is the rocket propulsion. The amount of gases, the force by which the gases are emitted by the rocket decides how fly the rocket will go up in the sky. This was the example we used for the Newton's third law of motion. That is, every action has equal and opposite reaction. Action was the force of the gases and the reaction was the flying of the rocket on the sky. We have also studied here today the 4 types of forces. Those are gravitational force, electromagnetic force, nuclear force, and weak force. We have also concluded that gravitational force and electromagnetic force comes under the category of classical physics, whereas nuclear force and weak force comes under the category of quantum physics. And this has been classified based on the particle size and the moving velocity of the particles. We have also studied momentum, where Momentum can be defined as the product of mass and velocity of the body. Further, in the last, we have studied torque, which is not the least. Torque is the rotational force acting on the body and can be calculated as the force applied multiplied by the perpendicular distance from the axis of rotation. That is, torque represented by del T or generally being represented by tau is equals to force applied, that is F, into perpendicular distance from the axis of rotation, that is R. So torque is equals to F into R. Here we close our today's session and today's classes. Hope you have learned very much about force, momentum, torque, etc. Thank you.